Day 7 Movie Recommendation System using Cosine Similarity. So, today we'll build a movie recommendation system using cosine similarity. The idea behind this project is to recommend movies based on how similar they are to a given movie, using cosine similarity to measure the similarity between the two movie feature vectors. So, let's start with our Python solution. So, I am going to start with a new file and says day 7. I'll say day 7.py. Now first, let's go ahead and import libraries. For that, first I will import pandas as PD. Now pandas is used to handle the movie data as a data frame, so that's why I'm using that. Next I will import cosine similarity. Now that comes from, I can get it from sklearn dot metrics dot something called as pairwise. This framework has our cosine underscore similarity. Next step that we need is we need the TF-ID F vectorizer. What it does is it converts text data, which is the movie genres, into numerical vectors using something called as the name says TF-IDF, which is term frequency inverse document frequency, which helps weigh words by importance in a document. So for that, I will say from sklearn dot, it's inside the feature extraction, and that has text which has this thing called as TF-IDF vectorizer. So once that is done, next thing I need a sample movie data set. Now you can use a real movie data set, but I have one that I'm going to use here. Now this has 5 movies, 1, 2, 3, 4, 5. Movie ID title is The Matrix, John Wick, Godfather, Pulp Fiction, Dark Knight, and genres are action, sci-fi, action thriller, and crime drama and action crime drama, depending on which movie it is. So I have that available. Next step is to convert the data set into a data frame. So I will say convert the data set into a data frame. So that I can do by df using the pandas pd dot data frame and pass the data to it. So that will create my data frame. Now if I want to display the data set, I can just say, let's say, display the data set, and that can be done using just the print command. I can say movie data, and that print the entire data frame. That's what I'll do because I don't have much data here. Next thing that I want to do is define a TF IDF vectorizer to transform the genre text into vectors. So to do that, I'll say TF IDF equal to TF IDF vectorizer. Let's see, TF IDF, perfect, vectorizer. And I'll also say it can take stop words. So I'll say use the stop words in the English language because it's all English. Stop words, what it will do is it will remove the and all those stop words that we have which are useless in a sentence. Next thing is fit and transform the genre column into a matrix of TF IDF features. So what I'm doing here is, so let's first create a TF-IDF underscore matrix equal to TF-IDF dot fit underscore transform, and I'll pass it the data frame with the the column genre. So what I'm doing here is I am saying convert the genre column into a TF-IDF matrix. Each row in this particular represents a movie, and each column represents a genre related word. The values are the TF-IDF scores, which weigh the weight of the word depending on how much is repeated, indicating how important each word is in each movie genre description. So that's what I am doing in this particular case. Now, the next step is to compute the cosine similarity matrix. So for that, I'll say compute, what did I say? The cosine similarity matrix. And to do that, I can just say something like I'll create a variable called as cosine underscore similarity or sim equal to, I'll use the cosine similarity that we imported. And to this, I can pass the TF-IDF matrix and TF-IDF matrix. Now, this computes the cosine similarity between all the movies based on genre vectors. This returns a cosine similarity matrix where each element, which is each tuple I and j, represents the similarity between the movie I and movie j. So it kind of cross references them. That's why I gave the same matrix twice. Now, next step is to, let me just move it up so you can take the entire screen. I am going to say, let's write a function to recommend movies based on cosine similarity. So that's what I'll do here. So I'll write a function, I'll call it get recommendation, something like that. Recommendations, and it will take the title of the movie, and it will also take the cosine similarity, which is cosine sim that we already have. So those are the variables that it will take. Now, first step here is there's like I think around 6 steps that we'll follow here. First, we'll get the index of the movie that matches the title. So I'll say get the index of the movie that matches the title. Now, to do that, what you'll do is like, let's say index equal to, from my data frame, I want to get data frame of title, which is equal to title and dot index of 0. So whenever the title of data frame matches the title, I want that item and index of item 0. So that will give me the index of that particular item. Next thing that I want to get is get the pair wise similarity scores of all movies with that movie. So I'm trying to get the similarity score for this, and the way to do it is I can just say similarity scores is list, and then I'll say enumerate through our cosine underscore sim with the index of id x. So what this does in the background is it returns the similarity scores between the input movies and all other movies. The result is a list of tuples where each tuple contains a movie index and its similarity score. So that's what it does. And next thing that I want to do is I want to sort them by similarity. So to do that, I'll say sort the movies based on the similarity scores. So to do that, I can just say same underscore scores equal to sorted, call the sorted function, pass the sim scores that I got from the previous one, and I'll have to pass a key. In this case, I'll give the key as lambda x colon x of 1 comma reverse equal to true. So what this does is sorts the movies by similarity in descending order, most similar first. That's what it does. And once I have that, I can get the indexes of the two most similar movies in this particular case. So I can do that by saying, so I can say get the indices of the two most similar movies. Now to do that, I can just say sim underscore scores equal to sim underscore scores and get the first element to third element. So that will give me exclude the movie itself, which is the index 0. So I'll get 1, 2, and 3. 1, 2. So those are the two movies that I'll get. If you want more, you can of course get more, but I just want two. And then I say get the movies. Get the movie indices. Now to do that, I can say movie underscore indices equal to I of 0. So I'm taking the first element for I in sim underscore scores. So as you can see, I didn't say for. Okay, so that will give me the movie indices. And next, I can just say return the titles of the most similar movies. So I need to pass it back. So I'll say return df of title dot iloc of movie underscore indices. So this will return the titles of the recommended movies. So I have the entire function written. Now next, let's test it out. So I'll say test the recommendation system with an example. So I can just say movie underscore title equal to, let's use the matrix. Okay, so I created that, and then I'll say recommended underscore movies equal to, I'll call the function get recommendations and pass the movie title, which will go in, pass the movie title, check the movie, get me the sorted, kind of get the similarity matrix and sort them out, and the first one movie will be removed and second and third will be displayed to me. So let's print it out. Print f of movie recommended for, what was our title? I can say movie title for this is, now this will be the recommended movies will be in list of items. So I'm going to say for movie in recommended movies, I want to print the movie. Since it's a list of 2 items, I'll display it out like that. So let's run it and check it out. So first, let's see, we are in the right folder. Clear it out. Python day 7.py, and it says the most recommended. So I displayed the movie list from based on what we've created, and then it says the movie recommendation for the matrix are The Dark Knight and John Wick, based on if you look at the matrix is action and sci-fi, and Dark Knight is action, crime and drama, and John Wick is action and thriller. So if I give The Godfather, it will give me Pulp Fiction because it's almost matches the same thing, and then Dark Knight also has crime and drama but doesn't give me the Matrix, or John Wick because it doesn't have crime or drama inside it. So that's kind of shows you how you can build a movie recommendation system using the cosine similarities. If you were not able to follow along, have any issues, let me know and I'll get back to you.